Hi.
Hi.
Please introduce yourself.
So I'm Benedikt Ahrens. I'm a Birmingham Fellow at the University of Birmingham. And in my research, I'm studying the meta-theory of type theory, in particular the meta-theory of univalent foundations. And I'm also striving to formalize all my results in a computer proof assistant, specifically in UniMath.
Thank you. Will you tell us something more about you?
Like what?
Okay, don't worry. Okay, what is the future of mathematics?
Mathematics becomes more and more important in all areas of life. And on the other hand, people don't really want to understand, we cannot oblige people to understand mathematics. So people become more reliant on mathematics, like in cryptography, when it comes to online banking and online shopping, and when it comes to autonomous vehicles, mathematics is everywhere. And at the same time, people don't want to be bothered with mathematics. People don't need necessarily to understand mathematics to use it. But then it's very important that the mathematics that we use, we can rely on it. We can know that it's true. So we need, I think, a solid basis or a corpus of mathematics, of computer verified mathematics that people can use without understanding the mathematics necessarily. So I think it's important that mathematics becomes usable without the need for understanding it. It can be used by a lot of people, by engineers, by other sorts of scientists, biologists, and so on, as a sort of black box for their work, because more and more of this work will require a significant amount of mathematics. So, yeah, mathematics is the future. It will become ubiquitous, but at the same time, people shouldn't be required to learn a lot about mathematics to use it.
Yeah, what expressed you to learn and search in mathematics?
Sorry, what?
What pushed you to learn and research in mathematics and univalent mathematics?
Univalent mathematics. Yeah, so I learned about type theory before I learned about univalent mathematics. I learned about plain type theory, what is now known as maybe Martin-Löf type theory. And there were always some questions that I did not quite understand about the behavior of identity. And I was really scared when I had to manipulate these identities and the transport of identities that came up without being properly explained. And then Wołodzki came up with his explanation of the identity type in Martin-Löf type theory that explained all these things that I had encountered but didn't understand, like the transport, the idea of an identity not as an equality but as a path. This gave me a good topological or graphical intuition for how to think about these identities that come up in Martin-Löf identity, that are the Martin-Löf identity type. And that motivated me to study univalent mathematics. It's really this incomplete understanding that I had before learning about univalent mathematics, about Martin-Löf type theory, and specifically about the Martin-Löf identity type.
Okay, some people say that the mathematics is a language. Is it this true? Is it true?
Yeah, is mathematics a language? I would say definitely. So, what is a language? A language is a means for communication. Somebody says something and somebody else hears something, receives it, hears or reads it. And that's done by language. So in mathematics it's the same, but somebody writes down some mathematics and puts it somewhere on the internet or on some archive, and then some other person can read and understand this piece of mathematics. So yeah, mathematics is a kind of language, and it's very universal in the sense that it is understood all over the world. And I would say it's even more so with the rise of computer-proof assistants, where you can easily send a piece of mathematics to someone else by email or put it online, and somebody else can just download this piece of mathematics. It's really a knowledge transfer that is, yeah. So yes, the answer is yes.
Okay, and what is the beauty of mathematics? People love beautiful things, and is mathematics have some such as beauty?
For me, what I like about mathematics is that it's certain. Everything in the world, in the real world, mathematics is disconnected from the real world in some sense. Everything in the real world is uncertain in the sense that things can happen that you cannot predict, and things are not under your control entirely. But in mathematics, everything is under your control. You can either prove a theorem or you cannot. I mean, if a theorem is true, then you can find a proof of it, and you can be certain that something is true because you have seen a proof. And if something is false, then you will find a counterexample. And so, for me, the certainty of mathematics is that it lies in its certainty.
Okay, how we can use innovative mathematics in real life, in everyday life?
I'm not sure that univalent mathematics will be immediately relevant to real life. As I said earlier, I think a lot of people use mathematics in their everyday lives, but they don't necessarily understand the mathematics that they are using. And it shouldn't be necessary to understand the mathematics that you're using or that you're relying on, just like you don't understand how the plane functions that you're sitting in, and that you hope it will bring you from A to B safely, or you don't understand your cell phone, but you're using it, you're relying on your cell phone without understanding how it works. And mathematics should be the same. People should be able to use mathematics and rely on mathematics without being obliged to understand it. So for many people, there will not be an immediate impact of univalent foundations on their everyday lives. But those people who create new mathematics and who build tools based on mathematics that are then used in turn by a wide range of people, by almost everyone, those people will hopefully or might feel the impact of univalent foundations, in the sense that hopefully sometime soon they will be able to mechanically verify their mathematical results in a computer-proof assistant based on univalent mathematics and univalent foundations. So it will be an indirect effect on people, and only few people might directly be impacted by univalent foundations. But a lot of people will indirectly feel the impact. Hopefully, that's a dream, not a prediction. Through the availability of more reliable software, of more reliable cryptographic protocols, of more reliable mathematical results.
Okay, and what you will say to students and teenagers that are thinking to learn mathematics?
Oh, yeah, you should do it. I was scared of studying mathematics, I must admit, when I was, I don't know, maybe I was 17 years old. I was thinking about studying mathematics. I was always fascinated by mathematics. But I was also a bit scared. I was scared that I wasn't capable enough, that I wasn't smart enough. And then I thought, one day I just thought, well, I will just try. And if it doesn't work out for me, then I can try something different. But I shouldn't not study mathematics just because I'm scared of it. I should at least try. And then I did, and it turns out that with a lot of hard work, I was able to study mathematics successfully. And in hindsight, I would say, having studied mathematics enabled me to learn other things very easily. Studying mathematics, sometimes people say, when you learn Latin, you can learn other languages very easily afterwards. So because what you learn when you learn Latin is like universally applicable, and you will discover patterns in other languages that you know from Latin. And I think it's a bit similar with mathematics. When you study mathematics, when you have a mathematical education, then you have learned to analyze problems. You have learned to take a big problem and cut it down into small, manageable problems. And you have learned to be precise in your analysis. And this knowledge will be applicable in many other disciplines. Computer science, obviously, but also it just gives you a general skill of organizing your thoughts in ways that will be useful everywhere in all aspects of life. So go ahead and study mathematics, and you will learn things that will be useful for the rest of your life.